Hello everybody, welcome back to my channel. So today it's time for a chemistry lesson. Today we will discuss about bonds. So the topics today to be covered are covalent bond, ionic bond, differences between covalent and ionic. So differences between covalent and ionic bonds. So without wasting any time, so let's get started. So now you may ask, what is a bond? So a bond is a chemical bond in terms of chemistry. So a bond is force of attraction between ions and atoms. This is the definition of a chemical bond. But bond is anything that keeps things together. So let's take one example of a chemical bond. H2O. It's a very similar. It's a common compound to everyone, which is nothing but water. Water contains many chemical bonds. So, like the force of chemical bonds. So, how is it possible? Let me say. The most important part for a chemical bond is valence electrons. So now you may ask, what are valence electrons? So basically, valence electrons are the outermost electrons in the shell of an atom. So now let's get back to shell of an atom. So in H2O, which is nothing but water, you can see there are two hydrogen atoms and one oxygen atom. So now hydrogen has a valence electron of 1 and oxygen has valence electron of 6. So how will the bond take place? So the bond takes place like this. So now you may not understand how it's taking place. So I'll show. Now hydrogen has 1 valence electron. This another atom has 1 valence electron. And oxygen has 6 valence electrons. So as I said in the periodic table lesson, for attaining stability, an element should contain 8 electrons in its outermost shell. So it occurs like this. Hydrogen will share its 1 electron with oxygen, and another atom also shares its 1 electron with oxygen. And oxygen shares all its 6 valence electrons with hydrogen. So the result is like this. Both hydrogen atoms will have 2 electrons in their outermost shell, and oxygen will have 8 electrons in its outermost shell. So every element becomes stable, as I said. So in order to attain stability, chemical bonds occur in order for elements to become stable and complete their octet configuration. So, as I showed the example, now we have discussed what is a chemical bond. So, let's move on. So, we discussed what a chemical bond is. Now, let's move on to types of chemical bonds. So, the first type of bond is covalent bond. So, now what is a covalent bond? A covalent bond is a force of attraction between two non-metal atoms. So, two non-metal atoms. Here, one electron is shared by each non-metal, and the pair is attracted to the positive nuclei of both atoms. Two nuclei. These bonds form molecules. So, as I explained about the covalent bond in the previous example, so there is a molecule, water. So, water has covalent bond, as I said in the before example. So, hydrogen has 1 valence electron, oxygen will have 6, and another hydrogen will have 1. So, in this case, as hydrogen and oxygen are both non-metal atoms, they both share electrons in order to attain stability. This is an example of covalent bond. As everyone knows that water is a molecule, so as I said in the above statement, water molecule as covalent bond form molecules. So this is one example. Let's go to the next type of bond. Ionic bond. So what is an ionic bond? An ionic bond is a force of attraction between two oppositely charged ions. In this, crystals form instead of molecules. So as I explained, ionic bond. Now let's take a look at an example. So let's take one common example, sodium chloride. You know what sodium chloride is? Nothing but our salt. So now NaCl. Now let's take like this. Let's use ionic bond in electronic configuration. So you can see electronic configurations of both atoms, sodium and chloride. The sodium's configuration is 2, 8, 1. Chlorine is 2, 8, 7. So now what? The sodium has one extra electron in its outermost shell. Extra electron in its outermost shell. Now chlorine requires one electron in order to attain stability, and sodium needs to lose one electron in order to gain stability. So now when sodium reacts with chlorine, the one electron here gets transferred into chlorine. Now sodium becomes sodium ion and chlorine becomes chlorine ion. So this is one example of ionic bonding. So sodium is a positively charged ion. In other terms, a positively charged ion means cation, and chlorine is a negatively charged ion. In other words, chlorine is an ion, which is a negatively charged ion. So now we have discussed about types of bonds. So now let's discuss about the differences between covalent and ionic bond. So let's move on. So let's get into some differences between covalent and ionic bonds. So ionic bond occurs between a non-metal and a metal, but covalent occurs between non-metal and non-metal. And in ionic, electrons are not getting shared, they are getting transferred. So transfer of electrons, here sharing of electrons in covalent. And here in covalent, in ionic bond, we have positive and negative charges. In covalent bond, we have no charges. In ionic compound, the room temperature is about 25 degrees Celsius, which is room temperature at 25 degrees Celsius, where they are solid in ionic. But in covalent, they can be any three states of the matter: solid, liquid, gas at room temperature. Then in covalent has low MP and BP. This means that MP means melting point, BP means boiling point, and here high MP and BP, melting and boiling points. So here in ionic there is weak attraction between molecules, weak attraction. It's a mistake. In ionic, it is high attraction between particles, and in covalent is weak attraction between molecules. So with this lesson, we complete covalent, ionic differences, types of bonds, and etc. Now let's go to a few examples in covalent and ionic bonds. So let's move on. So now, as I said before, covalent and ionic bond. Now let's take another example of ionic. Sodium bromide. So sodium bromide is an ionic compound, as it is a metal and non-metal. Bromine has 7 valence electrons in its outermost shell, and sodium has 1 electron in its outermost shell. So sodium transfers 1 electron to bromine and it becomes stable. It becomes Na plus Br minus. The the charge is cut and sodium bromide is the answer. So let's go to another question. When do you know N2? Yes, N2 is nothing but nitrogen. So how nitrogen share? There are two nitrogens here. They share in the following. So there is one N and here there is another N. They leave 2 electrons for them in the shell and share 3 pairs of electrons. Now each nitrogen is stable, 8, and here it is also stable. So now I am going to give some questions. So please answer those questions, whether they're covalent or ionic or any other. It is like an assignment for you. So complete it. So our first question is that now our first question. Show how two oxygen atoms share electrons. I mean, it's not show, it's tell. So the answer for this question is very easy. So now oxygen is there. Here another oxygen is there. So how do they share electrons? 2, 3, 4, 5, 6, 7 and 8. Oh, sorry. It's a mistake. So an oxygen has an electronic configuration 1, 2, 3, 4, 5, 6 and another oxygen 1, 2, 3, 4, 5, 6. So now how do they share? So the sharing of electron is shown by this. Therefore, the sharing of electron is shown by this. Oxygen share 2 pairs of electrons which is attracted to the positive nuclei. So they share electrons and become stable. Now I have another question for you. Tell me whether it is an ionic or a covalent bond. Yes, it's a covalent bond. It's a covalent bond. So let's go to the next question. So there is a compound sodium, let's not take sodium, let's take another. There's something called potassium iodide. So tell me, how do they share electrons and which type of bond it is? So the answer for this for this question is very simple. Potassium has an atomic number of 19, which means that it has a valence electron 1, and iodine has an atomic number of 53. And iodine just comes before xenon. As I showed, xenon is a noble gas, so iodine should be an halogen. So it has 7 valence electrons. So now what happens in this case is that potassium with a extra 1 electron, it transfers it into iodine. When it transfers into iodine, then iodine attains its stability and potassium also. So Ka will become 18, iodine will become 54. So potassium will become an cation and iodine becomes an anion. Both will cut and we get the crystal as potassium iodide. So what is it? What is this type of bond? Yes, whoever guessed it, it is an ionic bond. So thank you for watching this video. Please subscribe to my channel, and there will be many more science videos relating to physics, chemistry and biology. So thank you for watching this video. If you have any doubts, or put it in the comment section and write the whatever questions I asked, put the answers in the comment section. So thank you and see you soon.